Welcome to this explainer, where we are cracking open the examiner's actual playbook for Cambridge AS and A-level computer science. Now, before we get into the technical weeds, I want you to think about a master jazz musician. Sounds weird for a computer science session, right? But stick with me. A jazz musician can only improvise brilliantly and blow the audience away because they intimately know the underlying structure of the music. They know the rules inside and out, which means they know exactly how to bend them creatively. That is exactly the core concept we are using today. Improvise within structure. Know the rules before you break them. We are applying this directly to your Cambridge exams, whether you're looking at syllabus code 0417, 0478, 0983, 0984, 2210, and specifically our focus today, the beast that is 9618. We're tearing down a topic that looks so simple on the surface, but completely trips students up: utility software, and more specifically, defragmentation software. We aren't just reading textbook definitions today. We are looking at this exactly how a senior Cambridge examiner looks at it.
Okay, let's dive right into the ultimate challenge. What exactly separates a solid B grade from that highly coveted A star when you're tackling utility software questions? Look at the split screen here. On the left, we have an answer from a student we'll call Alex. Alex overloads the page with raw computer science facts. They're dropping terms like contiguous sectors and disk platters left and right, but there is zero analytical structure. It's a massive brain dump. On the right, we have Sam. Sam is panicking about the clock. Sam rushes, writes a single vague sentence about making the computer faster, and completely misses the actual command word in the question. And as you can see by all that red ink, neither of these approaches works. You might know what defragmentation is, but the difference between a good score and a perfect score completely relies on how well you truly understand the mechanics and the methodology. It's not just about what the software is, it's about proving to the examiner that you know exactly how to structure your argument.
So, to get you playing like a true jazz musician of computer science, we are mapping out the precise academic benchmarks required to absolutely ace this topic. We're going to systematically cover 5 key areas. First, the core principles. Second, the procedural framework. Third, mastering critical analysis. Fourth, the top examiner warnings that you desperately need to avoid. And finally, securing method marks. Grab your notes, because this is your blueprint for exam success.
Let's start with the foundational layer, the core principles of defragmentation. Because honestly, without this base structure, any higher order analysis completely falls apart under pressure. This is where we break down the command words. Are you being asked to identify, describe, explain, or evaluate? Because if the examiner asks you to evaluate the use of a defragmenter and you just describe it like our friend Sam did earlier, you are leaving marks on the table.
Now, what's really fascinating about how top students approach this is that they use a specific framework to answer. We call it the PEAL framework: point, evidence, explanation, link. Top-performing candidates don't just say defragmentation reorganizes data. That's just the point. They provide the evidence, it moves fragmented files into contiguous data blocks. Then the explanation. This reduces the physical movement required by the read-write head on a magnetic disk. They build a causal relationship. It's a structured, algorithmic way of writing an answer that examiners absolutely love. Before we continue on to the final step of that PEAL framework, I need you to do something. Subscribe to our YouTube channel, Ace the Exams, at acetheexams_IGCS to excel in your Cambridge examinations. Click that subscribe button and hit the bell icon right now. It seriously helps us keep creating these deep dive strategy sessions for you.
All right, let's talk about the L&R-PEL framework, the link. The principal examiner reports explicitly highlight that candidates who establish precise causal relationships and reference cross-topic connections achieve the absolute best results. This is how you improvise within the structure. Don't study defragmentation in a vacuum. How does reorganizing data impact the operating system's memory management? How does it affect the physical wear and tear on different types of secondary storage? When you can confidently link defragmentation back to hardware performance or resource management, you are screaming to the examiner, hey, I don't just memorize definitions, I understand the entire computer system. That is exactly what unlocks those higher boundary marks.
Let's move into the next phase and see how this all builds into the practical application of algorithmic thinking. We are talking about the procedural framework. This is where we take the messy, chaotic answers from our students Alex and Sam, and we transform them.
This right here is the exact 5-step computer science success blueprint. This is the methodology you should use to systematically tackle complex examination questions. First, deconstruct the command word. What do they actually want? Second, extract relevant context from the scenario. Is this a magnetic drive or solid state? Third, select your analytical framework, like our PEAL structure. Fourth, execute with clear logic. And fifth,
present it using precise, rigorous terminology. If you look at the screen, imagine we gave Sam 60 seconds to rewrite his vague answer using this exact 5-step blueprint. You can literally see the red pen marks turning into green check marks. He goes from "it makes things faster" to "it optimizes read speeds by creating contiguous data structures." The transformation is night and day.
To prove your mastery to Cambridge examiners, your procedural framework must clearly showcase these crucial algorithmic thinking requirements. When an exam asks you to apply practical thinking to a defragmentation scenario, they are secretly testing your ability to think like a programmer. They want to see step-by-step decomposition of the problem. If they throw a curveball and ask you to design a theoretical algorithmic solution, are you selecting the appropriate data structure? Are you prioritizing efficient code implementation? Are you considering how this utility would undergo rigorous testing and ultimately how you would evaluate its performance? This is the evidence-based reasoning they are desperate to see.
Stop scrolling. Subscribe to our YouTube channel Ace the Exams at @AceTheExams_IGCS to excel in your Cambridge examinations. We've helped thousands of students improve by 2 to 3 grade boundaries. Join them right now by subscribing to @AceTheExams_IGCS and turn on all notifications so you never miss our weekly exam strategy sessions. Okay, welcome to Section 3, Mastering Critical Analysis. Once you have the procedure locked down, it's time to tackle the hardest assessment objectives on the paper.
Let's run a quick interactive workshop right now. I'm going to put 60 seconds on the clock for Challenge 1, the data scan. Imagine a complex chart on screen comparing disk performance before and after defragmentation across different drives. An average student just looks at it and lists the similarities. They say, well, both drives got slightly faster. But the top answer, the ace jazz musician, they aggressively evaluate the differences. They use comparative connectives. They say magnetic drive performance improved by 40%, whereas the solid-state drive showed negligible improvement, conversely indicating that defragmentation is highly hardware-dependent. Do you see the difference? They support each comparison with concrete evidence from the scenario, and most importantly, they draw justified conclusions.
Now we reach the absolute most critical part of our explainer. This is Challenge 2 of our workshop, Finding the Flaw. We are going to look at the specific pitfalls that drag down student grades every single year. These are the top examiner warnings.
Examiners repeatedly sound the alarm on these 3 massive mistakes. For Challenge 3, our speed writing task, I want you to imagine writing a perfect paragraph in 30 seconds that avoids all 3 of these. Mistake number 1, answers are too vague. Writing, defrag fixes the computer, earns 0 marks. You need technical depth. Talk about read/write head latency. Mistake number 2, forgetting boundary conditions and edge cases in algorithmic questions. What happens if the disk is already 99.9% full? Can the defragmenter even run if it doesn't have a buffer zone to swap data blocks? Mistake number 3, ignoring the context. If the exam scenario specifically talks about a server farm using solid-state drives and you write a whole page about physical read/write heads moving across magnetic platters, you get nothing. Context is non-negotiable.
Finally, let's explore your ultimate safety net for those grueling, multi-step calculation or logic questions. Welcome to Section 5, Securing Method Marks.
I want you to read this direct quote from the Principal Examiner Report. Students lose marks by not showing working. This proves something massive. It proves that the evaluation of your algorithmic thinking, your actual process, is just as important, if not more important, than your final answer. It is honestly heartbreaking for examiners to see a student who understands the conceptual framework of data fragmentation perfectly, but they make one tiny logical error at the very end. Because they only wrote down their final answer, they lose all the points. Don't be that student.
This brings us to the complete answering system. To guarantee top marks, you need 3 rules. Number 1, command word decoding. Number 2, strict PEL framework application. And number 3, the time management matrix. Even if your final execution under time pressure is wrong, showing your logical, structured reasoning step by step will secure you vital method marks. That is the method mark strategy in a nutshell. Make your internal thinking visible on the physical page. If you are deconstructing a problem, show them the decomposition. If you are selecting a specific framework to evaluate defragmentation, write down exactly why you chose it. Examiners actively want to give you marks for your process. You just have to let them. This leaves us with a vital question to consider before your next study session. Are you just blindly memorizing theory, or are you truly mastering the methodology? The A-star doesn't go to the student with the biggest flashcard deck. It goes to the student with the most rigorous, connected approach. Listen, students who implement these computer science strategies see an average improvement of 2 grade boundaries, but only if they practice consistently with our weekly videos. Here's your final reminder. Subscribe to our YouTube channel Ace the Exams at acetheexams_IGCSE to excel in your Cambridge examinations. Subscribe right now to @acetheexams_IGCSE and click that bell. Don't let another exam pass you by. Drop a comment below with your target grade for computer science and the biggest challenge you're facing. Our team responds to every comment. Like and share this video with a study partner. Ace the Exams. Your Cambridge success starts here.